All right, well, hello physics students and welcome to this video lecture on Newton's third law. This is just going to kind of formalize some things for us in terms of Newton's third law. So our very simple definition for Newton's third law, and this is the definition that many people are going to give you. It says that for every action there's an equal and opposite reaction. Well, we can do better than that. What we really mean here is that for every action force, there's an equal and opposite reaction force. Now, what does that mean? Well, for every interaction, I want us to think back to when we first started talking about forces. Forces occur because of interactions between two objects. Okay, forces occur because of interactions between two objects. So now, because of this, we have these things called force pairs. Okay, because of interactions, we have these things called force pairs. One of those force pairs, or one of those forces in that force pair, is our action force. And then the other is our reaction force. Now, it's really important to know with Newton's third law that these force pairs, or this action and this reaction force, they have the same magnitude. So while these force pairs, this action force and this reaction force have the same magnitude, they are in opposite directions. Okay, they're in opposite directions. So that's what we're talking about when we say equal and opposite. This action force and this reaction force, ooh, I have a lightsaber today. Action force and reaction force, they have equal magnitude, okay, same magnitude, but they are in opposite directions. Now, a really quick example of this. Let's say that I have a bird. Imagine that that's a bird. Just so you know, that's a bird, okay? Now imagine a bird flying. It flaps its wings. By flapping those wings, this bird is applying a force to the air. So this is a force of bird on the air. So that is our action force in this scenario. Now we have to have a reaction force because forces occur in pairs. So our reaction force then is the force of the air on the bird. So we have to be careful with our verbiage here. Right here, our action force, this is the bird pushing down on the air. And here, this is the force of the air pushing up on the bird. So our action force here is force of bird pushing down on air, and our reaction force is the force of air pushing up on the bird. Now, we have to be a little careful when we're talking about Newton's third law. Because we say that for every action there's an equal and opposite reaction, many people believe that these forces just simply cancel out, and that's not the case. Because these forces are acting on two different objects. Okay? So we have some simple rules that we need to keep in mind when we're talking about Newton's third law. First is that only forces that act on the same object can cancel. Okay, an example of this is the force of gravity acting on an object and the normal force acting on an object. We know that a book just resting on a table is at rest because there are balanced forces there. That normal force and that force of gravity cancels out because those forces are acting on the same object. Okay, but we have to be careful. Those forces are not force pairs. That's not an action and a reaction force. And we're going to get more into that tomorrow. Our second rule is that forces that act on different objects do not cancel. And this is the key. This is the key rule right here to Newton's third law. Because forces occur because of the interactions between two objects. Okay, these force pairs that we're talking about, this action force and this reaction force, those two forces are acting on different objects. Those two forces do not cancel out. The reason that these forces do not cancel out is because they affect the motion of two different objects. So going back to our bird example up here, this force, this action force of the bird pushing down on air, well, that's actually moving the air. Okay, we can't see that, but that's actually happening. The air is moving because of this action force. And because of this reaction force, the motion of this bird is being affected. It's being pushed upward. So in summary, with these two rules, our first rule, only forces that act on the same object can cancel. This is because forces that act on the same object are only affecting the motion of that one object. However, for our second rule here, forces that act on different objects do not cancel because they affect the motion of two different objects. We're not just looking at one object anymore. We're taking a look at how those force pairs actually impact the motion of two objects. Okay, so in summary, Newton's third law, again, forces occur because of interactions between two objects, and as a result, we have these things called force pairs, where we have an action force and a reaction force. Those action and reaction forces have the same magnitude, okay, the same value, but they are in opposite directions. In addition to this, keep in mind these two rules right here. These are very important. When we're taking a look at one object, we can analyze that object, and forces that act on that object can actually cancel out because those forces are only impacting the motion of that one object. However, when we start getting into these force pairs and we're analyzing forces that act on different objects, we cannot say that those forces or those force pairs actually cancel out because those forces, the action and reaction force, are affecting the motion of two different objects. So I hope that this video shed some light on Newton's third law, and we're going to keep applying Newton's third law in the coming days. Take care, physics students.